Good morning, dear students. We were talking about concentration terms in chapter first. In concentration term, we have already completed the definition of molarity and the definition of molality. The definition of molarity, it is defined as number of gram moles of solute present in 1 liter of solution. Number of gram moles of solute present in 1 liter of solution is called molarity. Molarity changes with change in temperature because it depends on volume of solution. And volume depends on temperature. So when the temperature changes, volume of solution changes, and with the change in volume of solution, value of molarity will also change. It means molarity is not a reliable term because it changes with change in temperature. Second was molality, small m. It is defined as number of gram moles of solute present in 1 kilogram of solvent. Number of moles of solute in 1 kilogram of solvent. It is a reliable term because it does not change with change in temperature. Then comes concentration term number 3, that is mole fraction, which is represented by letter X. Now, how to define mole fraction? So, before we start the definition of mole fraction, let us assume a binary solution. Binary solution which is having two components. One is a solute and other is solvent. Solute plus solvent gives you solution. Because here we are having only one solute and one solvent, that's why solution is called binary solution. By rule or by convention, solvent is always represented by letter A and solute is always represented by letter B. If we have more than one solute, then we can use letter C or letter D also. Now suppose a binary solution is there. And in this binary solution, number of moles of solvent is Na and number of moles of solute is Nb. Then how to find out the mole fraction of solvent and solute? So here we can use the formula mole fraction of component A. Here we can take it A as a solvent, which is represented as XA, mole fraction of component A or mole fraction of solvent. It is equal to number of moles of component A or number of moles of solvent A divided by total number of moles. That is Na plus Nb. Na here represents number of moles of component A and Nb here represents number of moles of component B, that is solute. Now, if we want to find out the mole fraction of solute or component B, then we will write mole fraction of component B, that is represented as Xb, equals to Nb. That is mole fraction of component B or mole fraction of solute divided by total number of moles, that is Na plus Nb. Again, Na here number of moles of component A or number of moles of solvent plus Nb, number of moles of component B or number of moles of solute. So if we want to find out mole fraction of A, it will be number of moles of A divided by total number of moles. If we want to find out mole fraction for B, then it will be number of moles of B divided by total number of moles. So how we can define it? We can define it as, it is defined as ratio of number of moles of a particular component. It can be A, it can be B. Number of moles of a particular component to the total number of moles of all the components. Suppose we are having three components in the solution: A, B and C. Then how we will find out the mole fraction for the individual component? XA, that is mole fraction of A, will be equals to now Na divided by Na plus Nb plus Nc. Because in denominator we have to take all the moles or moles of all the components and then we have to add. Mole fraction for B, component B, will be equals to number of moles of B divided by total number of moles, that is Na plus Nb plus Nc. Mole fraction of component C, Xc, will be equals to Nc divided by total number of moles, that will be Na plus Nb plus Nc. Now, whenever we add mole fraction of all the components, let us talk about binary solution where we are having only two components. Then it is the rule that XA plus XB will always be equals to 1. It will be unity. If we add all the fraction values, then their sum will be equals to 1 or it will be equals to unity. Suppose we are talking about three component system, that will be XA plus XB plus XC will be equals to 1. Then we have mass percentage represented as W by W. Definition: it is defined as mass of solute in grams present in 100 gram of solution. As we are calculating mass of solute per 100 gram of solution, that's why this is called mass percentage. Mass per 100 gram of solution represented as W by W. First W stands for mass of solute and second W stands for mass of solution. Formula: mass percentage equals to mass of solute divided by mass of solution into 100. Suppose you are provided 20% CuSO4 solution. Then what does it mean? It means that if we talk about 100 gram solution of copper sulfate, then in 100 gram of copper sulfate solution we will be having 20 gram of copper sulfate. Remaining 80 gram will be water. Second case, if we are provided 50% CuSO4 solution by mass, it means in 100 gram of solution of copper sulfate we are having 50 gram of copper sulfate. We have dissolved 50 gram of copper sulfate. Remaining 50 gram will be water. An important thing, mole fraction, it is having no unit, it is a pure number, because moles divided by moles gives you no unit for this term, concentration term. Similarly, it is also pure number, it is having no unit, because gram divided by gram will cancel out gram, there will be no unit for mass percentage. And at last we are having volume percentage. How it is defined? It is defined as volume of solute in milliliters present in 100 ml of solution. Again we are defining it per 100 ml of solution. Volume of solute per 100 ml of solution. That's why it is called volume percentage per 100 ml of solution. Formula: volume percentage is equals to volume of solute divided by volume of solution into 100. Suppose you are provided 20% V by V solution of ethyl alcohol. What does it mean? It means that if we take 100 ml of ethyl alcohol solution, then in 100 ml of ethyl alcohol solution, we are having 20 ml of ethyl alcohol, remaining 80 ml will be water. So 20 ml plus 80 ml, 20 ml of ethyl alcohol plus 80 ml of water gives you 100 ml of ethyl alcohol solution. So it is all about concentration term. Thank you.